This is for page 33, the review and reflect. A copy of this page can also be found on MyMathLab. You can pause the video here in order to work it out on your own, or continue viewing to see it all worked out for you. The first thing we need to do is find the period for my function f of x is equal to 1 plus 3 tangent of 2x. Remember, the 2 is our frequency, omega, and we can find the period, t, by either doing 2 pi divided by omega or pi divided by omega. Because of tangent or cotangent, we're going to use this one to find our period. In our case, the period is equal to pi over 2, where 2 is our omega. So that answers the first one about the period of my function. The next one I'm going to do is the solve one. This is a radical. Remember, we need to get the radical by itself. So the first thing we're going to do is move the 1 to the other side. So I have 3 radical 2x is equal to 1. Then I'm going to divide by 3 to both sides. So I get square root of 2x is equal to 1/3. Then I'm going to square both sides so I can get rid of the radical. That leaves me with 2x on this side, and over here I get 1/9. Remember, that's 1 squared and 3 squared. That's how I get the 1/9. Then I need to divide by 2, and I'm going to write it like this, so that when you have fractions, to remind you that when you're solving for x, you're going to get the 1/9 and multiply by the reciprocal of this second guy. In other words, I'm going to multiply by 1/2. And I find that x is equal to 1/18. Solves this problem. The last one I'm going to do is to remind you about factoring. In this case, I have x squared, so I'm going to do x and x. Factors of 4 that subtract to 3 are 4 and 1. Because the 3 is positive, I need the bigger number to be positive, so I have a positive 4 and a minus 1 here. To double check, I know x times x is x squared. Negative 1 times a positive 4 does indeed equal to a negative 4. And in here I have a negative 1x and a positive 4x. And I can see that that does indeed equal to a positive 3x. So we are done factoring our trinomial.